Welcome to the September seminar. Thank you very much, Rigissa, for agreeing to present. So Rigissa will present gender role models in education today. And as usual, could everybody else please mute your microphones and feel free to ask questions. Rigissa is happy to take questions as she presents. So please don't hesitate to ask questions during the seminar. The seminar is being recorded and should be available hopefully by Monday at the latest on the GLO website. Okay, over to you, Rigissa.
Fantastic. Thank you very much, Matlub, for the invitation. I'm really happy to present this paper. Also, it's a great coincidence that on Monday we're going to have a working paper available for this project. And this is, as you can see, a project on gender role models in education. It's joint work with Sophocles Goulas, Bagua, and Yves Zenou. And the motivation for this project comes from the fact that we observe across settings and over many years this underrepresentation of women in STEM degrees, right? When you think about, and when we talk about STEM degrees, I believe we're all familiar with the science, technology, engineering, and mathematics context. Why is this something that creates kind of a puzzle? Because when we look at the data, we see that more women get a bachelor's degree overall. But when we look at the STEM degrees, we see that the pattern reverses. So we have many more men getting degrees from STEM, getting STEM degrees, obtaining STEM degrees. For instance, in physical sciences and science technologies, only 19% of graduates are females. When you look at engineering, only 18%. Computer sciences and computer engineering, similar shares. And one may say, okay, and why is this something that, we care about as economists? Well, we know that these STEM degrees pay better, right? So when we have fewer and fewer women obtaining a STEM degree, then we observe these gender pay gaps, and we really care about those gender pay gaps.
Can I ask a quick question? Where do you have econ? Because the definition of STEM for like OPT visas has changed over the last decade.
This is a great question. So in some definitions of STEM, based on some definitions, STEM is included, econ is included into STEM, but we're going to use the baseline definition in which we don't include econ into STEM. So in the baseline definition, econ is part of social sciences, right? So it's not part of STEM. So for now, I'm not going to refer to econ, but when we do a robustness check very later on, and we include econ and medicine into STEM, econ and business administration into STEM, which is the broader definition of STEM, the pattern remains very similar.
Okay.
So whatever I'm going to present is without econ, but when we include econ, results remain very similar. But that's a great question in general.
Yeah, I think just for international student, it's made a lot of difference, right? Because they didn't get the 3-year OPT with it before, now they do. So it has really changed the pattern of major choices for international kids who want to make sure they can stay in the US.
Absolutely, absolutely. This is a great comment. Right, so this is our broad motivation, but today I'm going to talk about role models, as you can think from looking at the title. And the motivation for these role models our motivation comes, for instance, from a survey that is conducted by Microsoft Corporation, in which they ask girls in many different countries why you're not choosing STEM, why you're not choosing STEM subjects as optional subjects, and why you don't specialize in advanced math and advanced physics. And girls cited the lack of female role models in STEM as a key reason they didn't follow a career in this sector. Right, so if I move to the next slide, you will see that this survey covered almost 12,000 women, and they were asked many questions about across these countries. You can see it's 12 European countries. And they asked them several questions about they don't want to specialize, they don't choose to specialize in STEM subjects. And they refer to several, factors, including the lack of role models and the lack of visible role models in those fields. Now, when you think about role models, who is a role model, right? It's probably to some of you straightforward, but it's not always straightforward. So in this study, and I think this is in line with a broad definition that we may have in mind, a role model is an individual who is perceived as exemplary or worthy of identification or imitation. So these are students these will be students who will be deemed to be worthy of identification and imitation, who are exemplary with regards to some dimension, right? So I'm not a role model because I want to call myself great, but I'm indeed really good in something. And the literature has looked at the impact of role models on educational outcomes when these role models are external speakers, when the role models are the parents or the teachers. And we know a lot about those kind of role models, those type of role models. But today we're going to talk about peers. We're going to talk about how peers can act as role models within a group. And when you think about, you may think that someone, for instance, an external speaker, right? Someone who is, for instance, ahead in their career, can give, motivation or advice with regards to career paths and choices. But when you think about a peer, right, how can a peer be a role model, or how can peers affect, the aspirations or the choices of fellow students? For now, I'm going to talk about that later on in details, but I want you to understand the motivation at this stage. And we think about these peer role models as being able to affect others by providing probably relevant information, or by improving the confidence, or make other students feel empowered, right? I can now see a role model who is, for instance, a female role model, for instance, in STEM, and I can now feel that I can also achieve that. I can be like them. I can envision myself as also someone who can be exemplary, or these role models can extend some students' possibility set. Something that I was not considering possible before now becomes possible, at least in my head, or alleviating stereotype threat. So this is the general motivation for this paper. And the exact research question that we ask is, can same gender peer role models mitigate to gender gaps in STEM? Now, why this hasn't been done before, why we haven't seen, or at least we have not been able to identify anything like this in the literature, right? There is discussion about role models who are external speakers, but there is no discussion about peer role models. There are some challenges with this, which we believe we overcome, but I want to mention what are these challenges. So we have identified at least 3 challenges in the literature. The first one is that high achievers in a peer group are not necessarily role models, right? So I may be in a peer group and I may be great in solving problems, or I don't know, in running or in playing an instrument, a musical instrument, but this is not probably something that makes me a role model, right? Then this is not something that is always salient, right? So other people in my peer group may not know that I am this exemplary individual. And when this is something that is not salient, how can others respond to that, right? It's not straightforward. The third challenge is that the assignment of this top performer in a group can be endogenous, can be based on specific characteristics, right? So we believe we overcome these challenges. We have a really interesting setting, and we are going to use top performers in Greek high schools. The nice features of this setting is that they are explicitly recognized by teachers. So the student who is, I'm going to give you a little bit more details as we move ahead. The student who is the top performer, who is scoring the highest, who is obtaining the highest performance across several exams, is going to be recognized as someone who is exemplary, as someone who is worthy of identification, and they call them role models, peer role models, because they are, fellow students within the classroom. These are same age students as the fellow students, and they will receive salient recognition on a daily basis for the whole school year. This is also something that is very interesting, because they will be assigned something from the teachers, right? And in particular, they will be in charge of what we're going to call later on attendance book. So they will be in charge of holding this attendance book, which gives them the recognition, because then everyone knows that they are the best performing student in the classroom. And we exploit this really nice feature of this design, which we have exploited in several papers by now, which is the quasi-random assignment of students to classrooms at the beginning of grade 10. Grade 10 is the first year of high school, and students are assigned to classrooms based on a lexicographic order, based on their surnames. So if my surname starts with A, B, alpha, beta, gamma, A, B, C, and so on, I'm going to be assigned to classroom 1. If my surname starts with the letter that is later in the alphabet, I'm going to be assigned to classroom number 2, 3, or 4, depending on the school cohort. And this is nice because it gives us a design that exploits this random variation. So peers are as random, the allocation is as good as random. Now, following this, the top performer will also be randomly assigned to a group, right? And then we have students being randomly assigned to either a top performer who is of the same gender or of an opposite gender. And that will be our main treatment variable. Of course, I'm going to show you later on that there is variation in this treatment variable, and this treatment variable is exogenous, right? So it's not correlated with student characteristics or classroom characteristics. So a female role model is not more likely, for instance, to be assigned to a classroom that has more females or a classroom that has higher performing students. So this is as random as it can be. This is the way we deal with those challenges. We believe we have a very clear contribution in the literature. As I said before, the literature has looked into the role of external role models. There are these two amazing papers out there, EJ and AJ applied. They look at the impact of having charismatic women who are later on in their professional career. So they're seniors, they have a career, going back to schools to talk to students or charismatic faculty members, going back to schools or universities to give a 30-minute speech about the benefits of studying STEM, the benefit of becoming a scientist or a professional in those fields. And they find positive effects of having female role models on female students. So that's established in the literature. These are great papers, but these are external role models, right? These are external people who have been hired somehow. CVs have been screened and they've been chosen to give this speech. This exposure is also kind of limited. It's usually 30 minutes or 1 hour. In our context, these peer role models come from within the group, so they're coming from within the classroom, and exposure to them is much longer than 30 minutes. Now, there is a second strand of the literature to which we believe we contribute, in which they look at the interactions, gender interactions between teachers and students. So female teachers in math and physics have been found to be very impactful for female students, right? So a female student who is randomly assigned a female teacher in math compared to a male teacher in math is more likely to perform better in math, if anything. And some of those papers, I mean, I'm also working in this literature, interpret these effects as the impact of having a female role model. However, these teachers are also instructors, right? And one could claim that their teaching practices and the pedagogies that they use are probably better received by female students. And it's not, the positive effects do not come from the fact that they act as role models, because they're also involved into teaching. So I may teach female students in a way that they understand better the content. So our top performers are not involved in any teaching activity. So we're really confident about the fact that we capture the role model influence, and we're not capturing some teaching efficiency or better match with respect to pedagogies. And also the third strand, and this is where how we started from, how this project started. There are these amazing papers, also very recent, that look at the impact of having more high-achieving females in math in my school or cohort. So what if by chance I'm lucky enough to be in a cohort that has more females that are high performers in math, right? And they find positive effects. However, that's how we started. And some studies consider the top 20%, some other studies consider the top 30%. So in our design, the 20 or 30 or 15, this cutoff was making the results sensitive. And that's why we moved away from this design. Additionally, we know as researchers, right, who is in the top 20 or what is the share of high-performing females in the top 20 or 30, but students may not know, right, because this is not something that is very salient in a cohort or in a classroom, probably. So our top performers are chosen based on an exogenous rule, and they receive salient recognition. So we believe we contribute to this literature as well. And as you will see towards the end of this presentation, we develop a model as well. After I'm going to talk about the empirical design, and I'm going to introduce this gender homophily context, right? So the same gender, so having a same gender top performer, I'm gonna present a theoretical model. This is just for motivation. It's a very simple idea in which we discuss traditional channels of peer effects like spillover influences and conformity influences, right? So I have a great student in my cohort or in my classroom. There are spillover effects coming from this student towards everyone else. There are conformity effects, so I want to be like them. I want to conform with them. And in this model, we're going to incorporate this new kind of idea of gender homophily, right? So of the gender match. I'm going to talk about that towards the end. Let me give you a bit more information about the institutional setting. So there are classes at the beginning of grade 10. Each class has a top performer who serves as the attendance record keeper, right? So within the first 3-4 weeks of grade 10, students have to take compulsory exams across all subjects. And these exams are graded. The student who has the highest overall performance is going to be assigned the attendance book. This is by law the student who scores the highest performance across all those exams. So it's not in the discretion of the teacher or the principal. And then they receive this attendance book and they are in charge of the attendance book. What does this mean? It means that in the morning, they're going to go to the principal office, pick up the attendance book, go to their classroom, have it in their desk. Teacher one comes, the first hour of the day, they will give the attendance book to the teacher. The teacher will record the absences. Is not the top performer. The teacher will sign this attendance book, this page, and then the record keeper will keep the attendance book in their desk, right? The second teacher comes in, third teacher comes in, they record the attendance, and then the attendance book stays with the top performer. They have the attendance book with them the whole day, right? They go around with this attendance book. So there is salient recognition on a daily basis. They do not teach, they're not involved in any teaching activity, and then they remain the record keepers until the end of grade 10. Our treatment will always be whether you have a same gender or an opposite gender top performer in grade 10, right? This is the first point of entry in high school. The reason is that this becomes more endogenous later on because there will be a new attendance, a new record keeper in grade 11. This is the student who scored the highest GPA in grade 11, in grade 10, excuse me, and then another one in grade 12. But we are not bothered with that. So our treatment will always be who was the record keeper in grade 10, whether it was the same gender or an opposite gender record keeper. That's how a page from this book looks like. So this student was absent the whole day. The first one you can see here, the first hour of the day, they had physics, French, ancient Greek, modern Greek, and history. And you see that the plus means that the student was absent. For the last 3 students, you see that they were only absent in the 4th hour of the day when there was modern Greek. And why were they absent? There is a note here which says that they were expelled because they were very noisy. And you also see that the teacher signs these absences, right? Great. Now, our record keepers are proud to be record keepers, right? So these are students who are really proud of being the exemplary students from their classrooms. And when we look at outcomes, I want to present this timeline because I want you to know what are the outcomes we're looking at. So we have initially students being randomly assigned to classrooms, as I said initially, based on their surnames. Within a few weeks, they take these exams. We claim there are not many interactions between students and teachers. Within these weeks, we have a whole section in the paper in which we look into that. So we have the selection of the top performer within 3 or 4 weeks from the beginning of the semester. Let me say that students come from different elementary schools, excuse me. So these are brand new classmates, right? So these are not my buddies or my friends with whom I was together in the previous grade. And then at the end of grade 10, all those students have to make important specialization decisions. They have to choose a track, right? And then they have to take track courses on top of core educational courses. The main decision they have to make is whether they're going to specialize in STEM or non-STEM. So this will be kind of our first order outcome. Actually, before that, we're going to look at end of grade 10 school exams in math and language. And then we're going to look at the track choice, which is the most important outcome up to this point, because they specialize after that in science or humanities. And then we're also going to look what happens, how does the assignment to a same gender versus an opposite gender top performer at the beginning of grade 10 affect their decisions 3 years later when they apply to universities. So at the end of grade 12, which is the senior year of high school, they take standardized exams, and then performance in these exams determines to a large extent university admission. And we have also information on the degree they enroll, right? So we're going to look at whether they're more or less likely to enroll to a STEM degree. Great data. We're really proud of the data that we are using in this paper. We combine data coming from the Ministry of Education in Greece from 2003 to 2011. So this includes everyone who took these national exams in grade 12, at the end of grade 12. Everyone who is considered to be applying to universities. And for them, we have access to whether they enroll to a post-secondary institution, the name of the institution, the field of study, the applications they made to specific university degrees, and the quality of the degree that they actually enroll. And we combine this. So this is one point in time, right? You can't do much with one point in time. So we had to go back to the high schools and collect information about grade 10 and 11. So we managed to collect data from 105 high schools. That was an extensive effort by visiting the high schools, right, which are spread across Greece. I will show you in a bit. It took us many years, 4 or 5 years, but we've been using this data on many projects. So this is not the only one, which is great because this pays off. This great effort pays off. We have information from around 10% of the school population. So there are a little bit more than 1,000 schools, high schools in the whole of Greece. And this is a representative sample, as we saw in the paper. Now, what do we have for these students? What data we collected? So for grades 10, 11, and 12, we collected information on every exam they take, school exam or national exam, in every subject that they take exams. We collect information on the track choices that they make and some demographic characteristics. We also know who is grouped together with whom. We know the classes they attend, the class numbers they're assigned to. We merge this information with the information from the Ministry of Education. So we can actually track all those students from the beginning of grade 10 up to the moment that they enroll to some university degree. This is a great panel data set. And it covers more than 60,000 students, right? Then we started presenting this paper last year, and then there was this question of why, right? Why do you find the effects that you find? So we decided to go back and do a lab in the field experiment in which we visited some schools, a smaller sample of schools, much smaller, 6 or 7 schools. These are not the same students that we observe in the admin data or the primary collected data. These are some other schools. But the idea there was to try and replicate the experiment. So we randomly assigned students to profiles of top performers via a survey that we disseminated while we were visiting the schools. So it's a survey-based randomized experiment. And then we asked them a lot of questions about how they perceive these students. So they were either assigned to a female or a male top performer, right, randomly. And then we asked them a lot of students about how they think this top performer could affect them, what are their perceptions about those top performers, and most importantly, why, right? So we were able to validate our findings from the natural experiment in the lab in the field experiment and also understand why this may be the case.
This high school data that you collected, which years was that? Over what time period?
Same year, so 2003 to 2011. That's a great question. Sorry, I didn't mention that. It's 2003 to 2011, so we have information for the same students in the same years. That's why we were able to match them. So we collected information from several schools, which are located in several cities. You know, this is Athens, the capital, but we also went to the north. We went to some islands, Crete, which is the largest island, and then Peloponnese. So we have a lot of variation in the location of those schools, which we also exploit later on, because it's an interesting question to know, for instance, whether these peer role model influences are more pronounced in more disadvantaged settings compared to less disadvantaged settings. Great. I'm not going to show you a lot of descriptive. I have a lot of slides and I have many interesting results. I just want to tell you that overall, 52% of students are assigned to a same gender top performer, and 68% of females are assigned to a same gender top performer. Why is this share higher for females compared to males? Because there are more female top performers, right? As you will see in the next slide. 68% of females are assigned to a same gender top performer. And then 33% of males are assigned to a same gender top performer. So this is the variation we exploit in the main specification, right? And there is enough variation. So indeed, we have more females assigned to a same gender top, but there is enough variation that we exploit. Now, it's important.
Are most of the record keepers women then?
Most of the record keepers are women, yes, 65%. It's not that we have majority, but there are more proportionally.
So I just don't want to forget, I was thinking about it when you said it's the first year, kind of that first exam, but they haven't really, I mean, that's really based on sort of their like the knowledge from the elementary school, right? Not really how they're doing.
Exactly.
I was wondering if maybe in your future project, since this is such a unique data, you could actually exploit the transition to grade 11, where that's based on their performance in grade 10. Because I suspect that a lot of the girls that did well on that entrance exam might not, retain that status with the like overall GPA in grade 10, and maybe looking at whether that role model stayed, like if she remained in the position or if it was somebody new, right? Because I would think that someone who remained might have like a stronger role model effect. that it kind of confirmed the initial test, right? And versus somebody who became a new record keeper.
Right.
It might be worth looking at as just kind of a small side on something, but I couldn't stop thinking about that when you were describing that it could sort of be accidental, right? Because it's based on one set of exams versus the record keepers in grade 11 are based on a full year of performance and their overall GPA, that it's kind of a stronger signal. But I understand the selection
We
problem.
can do that, actually. We can do that. It's very easy to do that because we have the data, right? So
Yeah.
this is something that we haven't done, and this is a great comment. Thank you.
I just also, I mean, related to kind of that, because one of your key things is the recognition by the teachers. And they are saying, so I don't know if gender of the teacher is also kind of
This is a
playing
very
part.
relevant
So you
question as
could have
well.
an interaction in a way of the same female performer and more recognition by female teachers versus male teachers, or something to the effect there where, because you're talking about the performer peer performance, but it is really coming from that teacher kind of recognition thing. So I want to be a good boy, you know, because I want to be recognized as well. And so that could have an impact.
This is a great comment. So we have a section in the paper in which we know the gender of the teacher for some of the teachers. 65% of the teachers are females indeed. We don't find that the effects are driven by female teachers. Also, there is a teacher mix, right, with respect to the gender. So they don't only have female teachers or only male teachers, but we do investigate this more formally in the paper. This is a great comment. This is one of the first confounders that my mind also went, but this doesn't seem to be going on here. But thanks for the comment. So then we want to establish that it's important to establish for the causality of our findings that this is indeed a random assignment of students and teachers to classrooms. And we've exploited this by now in several other papers. So it's easier for us now to convince, especially our referees, that this is indeed the case. But I want to show you a few exercises here. So first of all, we do a balancing exercise at the classroom level. So we stack everything at the classroom level. As you see, the number of observations here becomes equal to 3,055 because we have 3,055 classrooms. And we run the predetermined variables and the variable of interest as outcome variable. We run regressions in which the outcome variable is the controls that we have and the treatment variable against the classroom numbers. So if there are, for instance, higher performing students in mathematics in the first classroom compared to the other classrooms, we would expect to get positive effects here. So let me say we exclude classroom number 6 from here. So this is the point of comparison. This is the omitted category. So if classroom 1, for instance, had substantially students of substantially better baseline performance in mathematics or language, that compared to classroom 6, that would be positive and statistically significant. And then we include all the predetermined variables that we have at the student and the classroom level, as well as the main variable of interest. This is our treatment variable. Here I'm showing you results excluding class number 6, but it doesn't matter if you exclude 6, 1, 2, 3, 4, or 5, the results remain very similar. And the main point from this table is that you see that they are jointly not significant, right? So you see the p-value is overall really high. You see numbers that are relatively close to 0, practically 0. You don't see a lot of stars, right? So you have a couple of stars here and there, but there is no pattern. There is no persistent pattern that would indicate that one of the classrooms has on average students of different characteristics compared to the other ones. Then we do an exercise at the student level. This is the point in which I should say that I'm going to present you results separately for males and females, right? So we run all the analysis separately for males and females because it's easier for interpretation later on, but also because females and males may react in a very different way to these peer role models. So here we include the outcome variable on the left-hand side of those regression. We run kind of the standard balancing exercises. And then on the right-hand side, we include some predetermined variables, one by one or simultaneously. You see that these numbers are practically zero, right? You don't see correlations between being assigned to a same gender top and, for instance, performance in math for men or for women. So these results give us confidence that indeed this top performer is randomly assigned across classrooms and across students. Right? So we can be convinced in a sense that our design is as good as random. Then the next natural question is, who are these top performers, right? Who are these people? Let me tell you that I don't have this information here, but the overall performance of men and women is very similar when we talk about the top performers. So top performing females and top performing males have the same overall performance. In this table, I'm going to split it into math and language. And I'm going to look at top performers in panel 1. I have 3,157 top performers. And I'm going to look at the differences in their baseline performance in math and language for females and males. And I'm going to do the same exercise for every other student in the class except of the top performers. As you can see, I have 58,000 observations here. And there is an interesting pattern here. I'm going to start with the second panel. When we look at males, let me start with males. You see numbers that are out of 20. Let me also say that this is the raw test score, right? This is out of 20. 20 means the highest achieving performance one could get. 0 is really low performance. You see that the average performance of men, of every student except of the top performers, is equal to 14.2, right? Their average baseline performance in math is equal to 14.4. So students, not at the top, but everyone else, men, students, are performing better in math compared to language, right? This is in line with what we know from the literature, right? That men are better in STEM compared to non-STEM. When you look at the top, when I look at panel A, this pattern remains the same. So men, top performers, perform better in math in their baseline exams compared to language. So they're kind of STEM top performers. And let me now look at females, right? We know from the literature that females are performing better usually in humanities compared to math. Is this what we observe in panel B here? So in language, females, they get an average performance of 15.1. In math, they get a lower performance, a 14.5. So females, not at the top, but every other female in these classrooms seems to be performing better in humanities, in language compared to math, which is what we would expect based on the knowledge of the literature. But at the top, these females are actually different, because the top performing females that we have are actually performing better in math. They are probably STEM top performers, right? They are perceived to be STEM top performers, probably by other students in the classrooms. And this is also reflected in the choice of track that they make at the end of grade 10. Although there are more females who choose to go to classics degrees in general, not at the top. At the top, most females go to STEM tracks. So our top performing females seem to be really, really unique with regards to this tendency to go to STEM tracks and excel in STEM degrees. This is important for later on, and I'm going to motivate some results that we have based on this finding, based on the fact that female top performers are probably perceived to be as STEM top performers. Let me tell you what is the main specification that we use. Hopefully, I convinced you that being assigned to a same gender top performer is exogenous. And we're going to look at the impact of being assigned to a same gender top performer compared to an opposite gender top performer on several student level outcomes, while we control for student own characteristics, gender, baseline performance, and so on and so forth. classroom level characteristics. I'm also going to control for other characteristics of the top performer, right? Because gender is one dimension that could affect being assigned to a same gender versus an opposite gender. But there are other characteristics of the top performers that could also affect students in the classrooms. And this is really important. I'm going to include school by year fixed effects. So the variation I'm going to use is coming from within school cohorts, within school years. So within 2003, let's say, in this particular school, which has 4 or 5 different classrooms, I'm going to compare students who look very similar with regards to their demographics and with regards to their baseline performance. Some of them are assigned to a same gender top, some of them are assigned to an opposite gender top. And this is the comparison I'm going to make. I'm not going to compare someone who is assigned to a school in the north part of Greece to someone who is attending a school in the island, right? It's always within school cohort. And the second important thing I need to mention here is that after we derive the characteristics of the top performers, and I derive this variable here, the treatment variable, and I also control for the characteristics of the top performers, I'm going to drop top performers from the analysis. So this is all about how exposure to those top performers and the gender of those top performers affects other students in those classrooms. Great. So now for the next few tables, hopefully I can go a bit faster because I'm going to show you tables that indicate the same pattern. So results are going to be run separately for males and females. And I'm going to present 2 specifications for males, 2 specifications for females. Actually, 2 specifications for all the results. Let's focus on the most augmented one. And I have performance in mathematics and language at the end of grade 10. This is the first outcome I'm going to look at. With regards to language, you see that there is nothing going on. These estimated effects are practically 0, and there is nothing that could indicate that assignment to a same gender or an opposite gender top performer could improve or deteriorate the language performance of those students. When I look into math, though, males, similarly to language, are not affected. There is no effect on males' performance, subsequent performance in math, but there is an effect on females' subsequent performance in math. So females who are assigned to a same gender top, who are assigned to a female top performer, compared to females who are assigned to an opposite gender top performer, seem to be performing better in mathematics. So this is equivalent to 5%, and this is not a negligible effect. The next outcome I'm going to look at is whether they are more likely to enroll into the STEM track at the beginning of grade 11. This is a choice they make at the end of grade 10, right? So they need to sign a piece of paper. They need to fill in a piece of paper in which they report which track they want to enroll in at the beginning of grade 11. Females who were assigned at the beginning of grade 10 to female top performers are 3 percentage points more likely to enroll to a STEM track choice compared to females who were assigned to male top performers, opposite gender top performers, which is in line with what we saw earlier, right? They perform better in math, they're more likely to enroll into STEM. Do we see anything for men? No, there is no effect for men. There is no effect for men for all the tips I'm going to show you actually from now on. So probably I will stop commenting on them. But for females, so far, there seems to be a persistent positive effect on their STEM outcomes. Then we look at what happens, remember the timeline, 3 years later, whether they are more likely to apply or enroll to a STEM university degree. This is great because we have access to their applications. We have access we know everything about their applications. For men, there is no effect. Females are 3 percentage points more likely to apply to a STEM degree when they were assigned to a same gender top performer, to a female top performer, compared to females who were assigned to an opposite gender top performer, a man. And they are also 1 percentage point more likely to be admitted to a STEM university degree. At this point, you may say, oh, but 1 percentage point is probably nothing, right? Well, it is not much, but only 6% of females enroll to a STEM university degree. So it's not a negligible effect. So far we see that exposure for females to these female top performers seems to have a persistent effect throughout the whole high school career and also affects their university admission choices. Then we look at enrollment to a university degree in the top 20%, different ways, we get the same result. Females are more likely to enroll to a higher quality university degree. Then we ask the question of how do they react? So far, in the previous table in which I showed you effects on STEM choice, it's just exposure to a female top performer, right? So here we look into the mimicking behavior of those students because we say, how do females and males react when the top performer chooses a STEM track? Are they more likely to follow this choice, or are they more likely to deviate from this choice? So females who had the top performer choosing a STEM track choice at the beginning of grade 11 are more likely to go to STEM as well themselves, right? Compared to females who had an opposite gender top performer, again, no effects on male students. We do a lot of heterogeneity, placebo, and additional analysis. Let me say that effects are mainly coming. I'm not going to click on all those buttons because I have many more things I want to talk about and I have only 14 minutes. Let me say, though, that the effects are much more pronounced in low-income neighborhoods, right? So females who are assigned to female top performers in deprived schools are much more likely to make those choices, are much more likely to perform better in math, much more likely to enroll in a STEM degree, to enroll in a STEM university. That's a very interesting result. Then we do a lot of placebo exercises in which we replace the top performer with other random students, or the top performer from the other classroom, or the top performer from a different school cohort, and we find zero effects. So that makes us very confident in the fact that we are actually capturing this effect of the top performer in their own classroom, rather than any spurious effect or something else that it is happening at the school cohort level.
Rigissa, sorry to interrupt. It's actually less than that. It's about 6 minutes because we want to leave a few minutes.
Okay. We then do an additional analysis. I'm only going to mention this. So instead of now think about the top performing student, there is a second best student and a third best student in the classroom. Their difference with regards to performance is not much, right? It's minimal. So when we replace our treatment variable, which is same gender top, with same gender second or same gender third, so whether my gender matches the gender of the second best performer or the third best performer, we find zero effects. So this is an effect that is coming from the salient recognition of the top performer, because this salient recognition is what the second and the third best don't receive. Robustness, a lot of robustness. Then we go back to schools. We design a survey experiment, which we disseminate to 606 participants. We expose them to different profiles. I'm going to show you the profiles. We ask them about perceptions. We ask them about mechanisms. We ask them about the real experiences in a 10-minute survey. These are the profiles that they see. The 2 females and 2 male profiles. We weren't sure whether we should indicate something in STEM or non-STEM, so we also randomized the STEM and non-STEM, as you can see on the whiteboard. But the main treatment is whether you're assigned to a same gender or an opposite gender top profile. And then we ask them about whether exposure to this boy or girl would be an example for them, right? I don't have this here, but we ask them, we show them the profile and we ask them the question on the same page. And we find that female students, so think about that, these are other students 10 years later, right? So this is a 2023 lab in the field experiment. So those female students who were exposed to the female profile on the questionnaire that we circulated are 22% more likely to say that the female top performer that they see on their screen will influence their STEM performance. So this is a perceived influence on their STEM performance, right? Because here we say, how would they affect your school performance in STEM subjects? For men, we find a much smaller effect, an imprecise effect. And then we ask them about why. I'm sorry, I need to rush up, right? I have probably 1 or 2 minutes. This is really nice because for men, we don't find any effect in line with the natural experiment that we have. So they don't seem to react to being assigned to a same gender versus an opposite gender top profile on the survey. But for females, there are some positive effects that come from self-confidence. So females who see the picture of the female top performer on the survey that we circulated, compared to those who see the boy on the questionnaire, are more likely to report a higher self-confidence when they're assigned to the female, and an increased sense of distinction feasibility. So we asked them that C would make me feel that I can also excel and stand out. So now I feel that this distinction is feasible for me. Great. We asked them about the real track choices, and we asked them to report the gender of the top performer in their classroom. These are grade 11 students. And probably I have 1 minute or even probably less to talk about the theoretical framework. This is an interesting exercise because we call this now gender homophily, right? The tendency to associate with the gender of the top performer. The literature has studied homophily in general with regards to age, race, religion, education, and so on and so forth. And there is evidence that this homophily can actually play a role when we talk about peer effects and social interactions. We focus on gender because that's what the design is ideal for. We incorporate these traditional effects, peer effects, spillover effects, and conformism effects. There is literature about that, especially spillover. Conformism is something that is kind of newer. And the idea is that we have this very simple model. It's indeed a very simple model, in which we also include this homophily term. So the spillover effect and the conformism effect depend on my baseline effort, my baseline performance, and the baseline performance of the top performing student. So if the top performing student in my classroom is of higher baseline performance, we will see later on that this beta S is positive. So I'm going to exert more effort. Now, there are conformism effects as well. So I want to conform with them. So the smaller is the difference between my baseline performance and the baseline performance of the top, the more effort I exert, because I can see now that I can reach them, right? They're not out of reach. Now, an important thing is that, and I will show you later on in this 1 minute that I probably have or less, that these spillover effects and conformism effects are the same for boys and girls, which is very interesting, right? So boys and girls exert the same spillover effect. So that when they have a better top performer, they wanna perform better. When they are closer to their top performer, they wanna when they're closer to the top performer's performance, they want to perform better. But this gender homophily term, this beta H, is what we've seen so far that reacts differently. Let me go directly to the results. I'm going to show you now 3 terms: gender homophily, conformity, and spillover. You will see that for males and females, the conformity and the spillover are extremely similar, statistically similar, right? You see a negative conformity and a positive spillover throughout all the outcomes that I've showed you so far, and this is the same for boys and girls. But when you look at the gender homophily term, you see that only females react to this gender homophily term. The last sentence I'm going to mention is that we managed to come up, because this was our homework for a long period of time. Why is this the case? Why we find similar effects for conformity and spillover, but different effects for gender homophily across genders? And we have managed to come up with an answer to this. So the spillover term and the conformity term, they both depend on the performance of the top performer, right? You see this Y tilde top term in both terms. And the important feature of our design is that our top performers, as I mentioned at the very beginning, have the same baseline performance, overall baseline performance, because as I told you earlier, some are considered to be STEM top performers, and some are considered to be non-STEM. But their overall performance is very similar. So what seems to matter is not the performance of the top, but the mere presence of the top in the reference group. And this is what is probably driving this differential by gender effect on beta heights. I don't have time to talk about more things that we have. This is part of a research agenda. We're really excited about this paper. We're really excited about every paper in the research agenda. And I'm happy to take any questions you may have.
Great. Thanks very much, Rigissa. So we have time for a couple of questions. Anyone?
Maybe I have a question. So do you know, can you follow them after, like in the labor market? Or let me put it differently. It would be nice to know whether it's a good thing for the people to be nudged into STEM or not. Was it good for the students to have a higher probability of enrolling in that career? I think so. On average, the data tells us so. But if you could show that, I think it would be very nice.
This is a great comment. Unfortunately, we cannot follow them. No, there is no way to link their later outcomes with performance in college or high school. And when we interview them, they are in high school, right? So but that's a great comment.
For back of the envelope calculation could just be if they were to get the average STEM salary, if they go through university and get the average STEM salary, then you could calculate a number that I'm not sure a lot of people would believe in, but it would be how much more money that they have made by being randomly assigned to a female top performer. It could be an interesting number to have.
This is a great point. A dollar number always helps. A dollar figure
always helps, exactly.
Yeah,
Nobody believes it anyway, but you have it at least.
Yeah, but they want to see it probably, or they want to hear it. We haven't done that, and we can do it, which is a great comment. So what we've calculated with the back of the envelope calculation is that these same gender peer role models can reduce the underrepresentation of qualified females in STEM based on the degrees that they enroll in by 6 to 9%. That's the only thing we've done. But we can come up with a dollar figure. It's a great suggestion. Thank you.
So my bigger question on this was, though, how would you motivate, what policy would do this, right? Like the first thought is, okay, so let's have girls be the record keepers. But then if it's not earned by that exam score, is it going to really have the same effect as a role model? Like if you just mandated that the record keepers are girls, right, then it's kind of going to lose the perception that they're special or that they're someone to look up to. So how would you actually put this into a policy motivation, right? Like what could you do? I mean, it's great to show that it matters, but how do we increase the women role models?
Right. This is a great question as well. We've thought a lot about that. Because we can't say now, okay, so we don't have treatment versus no treatment. We have just same gender versus opposite gender, right? We don't what other papers have, in which they have the exposure versus no exposure. So that's a very interesting question. So one way is to think about it in that way. So you want to make probably females act as record keepers, but you cannot have a female act as a record keeper in every class, right? One could say probably you can assign, the record keeper to the top performing male and the top performing female, so that they can both potentially affect their classmates. But even that is not clear how could help. And that's something that we probably need to put more thought on. we find these really nice results,
Yeah, but
intuitive
then what,
results,
right? What can
persistent
we,
results.
yeah.
Absolutely. We understand now the influences. We understand that the gender of these role models matters a lot through these kind of peer effect influences. But it's true that the policy implications, I mean, one thing we can say is that, assigning recognition to someone from within the group is probably more natural, less costly compared to hiring someone from outside.
Mhm.
But I'm also cautious about, answering your question directly because it's tricky.
Any
I have a conceptual question. Well, the driving factor seems to be confidence. This is right. Girls are more
Exactly.
confident. That's why I'm doing it. Now, let's look in a dynamic world. If more and more girls are in STEM and this becomes more natural, would this effect then go on or not? Is it, I mean, are girls predetermined somehow, not by genes, but by education, that girls are not able to do STEM, and now the role model helps. But as soon as this disappears, and we see, of course, over the recent years, such a rise of competence among girls, this effect you have found may not be stable over time. I mean, that's an issue.
That's a great comment. Now that you are saying that, I think we can actually look into classrooms or school cohorts that have a lot of females, right? So we can plot the distribution of female share and look at extreme cases and see whether, when 70%, for instance, of the classroom are females, or whether when they perform well in math, whether these peer role model influences still survive.
Okay.
That's a great comment. Because you expect the female to have a larger influence when there are not so many females performing well in math. But when they do perform well in math, which is probably what you say, do we have the same effects? Do we observe the same effects? We can actually look into that in the data. That's a great comment.
Okay.
I think we'll stop here. Thank you very much again, Rigissa, and for everybody
Thank you.
else coming to the seminar. And until next month, goodbye. Thanks very much.
Thank you, everyone.
Presentation and really good paper.
Thank you so much. Great comments.